to take a look at section 2. And in section 2, we're going to talk about inductive and deductive reasoning. Inductive reasoning is making conjectures or like a hypothesis, a guess of what you think is going to happen. We give examples of correct and incorrect inductive reasoning here, and we want to be able to distinguish it from deductive reasoning. Inductive reasoning is the process where you come to a conclusion based on observing a pattern. And we would call that conclusion a hypothesis or conjecture. So if every day when you go to town at 8 a.m. there is traffic, you have observed there is traffic, and so you're going to say every day of the week at 8 a.m. there is traffic because you have actually physically observed that. And so here are a couple of examples. If I consider the numbers given, and if I want to look at A, C, and F and say these aren't evenly divisible by 9, but B, D, and E, A, C, and F are evenly divisible, B, D, and E are not, let's add up the numbers and see what happens. And then I want to make a conjecture because I'm actually walking through the example right now. So if I add up all the digits, I see that A, C, and F are all factors of 9. B, D, and F and E are not factors of 9. So I've made something that's an observed pattern. And so my conjecture is that for 9 to divide evenly into it, it must have a factor of 9, and that would be right. So I actually hands-on did it and then made a conclusion. And so this is related back to the always principle. When we're doing inductive reasoning, I'm making a guess. I'm not saying this is always true. It's truly a guess. So you want to be very careful. That's why it's a conjecture. That's why it's a hypothesis. I can use inductive reasoning incorrectly. So if I want to divide a circle into regions by selecting points on the outside of the circle and then drawing line segments. If I look at the figure on the next slide, you'll actually see this. And I want to use inductive reasoning to find the greatest number of regions that I could get if there were 6 points on the edge of the circle. And so at first I'm like, okay, 1.1 region, 2.2 regions. If I stopped there, my conjecture would likely be 3.3 regions. But notice what happens. I go to 3.4 regions and 4.8 regions. So my whole hypothesis is out the window by the time I look at 3 and 4. So you can't just try like twice. You need to try several different times to see what the outcome is. And so the actual largest number of regions is going to be 32. Deductive reasoning, on the other hand, are what we use as accepted facts. These are facts that we are taught previously. A proof is one. Step-by-step, PEMDAS, it's deductive reasoning. We've accepted that we do parentheses first, then exponents, and then we move down PEMDAS. We've accepted gravity. Gravity is a rule or a principle. It's there. We accept that it exists. And so if I want to use deductive reasoning to solve puzzles, in this example, I have 4 students, and they're all in different activities. And so I want to use these clues to determine what each student does. And so I'm given 2 clues here, and then I'm giving 2 more with 3 and 4. So I have a clue for each person. So to organize my thinking, I would probably want to take those clues and list them under the person's name. And that would let me kind of have an idea and track the information. I could also put an X if there's an eliminated possibility based on the clue for someone else. And so if I did that, this would kind of be what I came up with, is this sort of table that's going to help me organize my information. So clue 2 tells us that Noah does not play in the orchestra, and clue 3 tells us Carmela is not a basketball player. So then I know I can cut those out. Then I know that we can place 3 more X's in the table. So if I follow those clues, this is what it starts to become. And so I have 4 options, and I've ruled 2 out for C and 2 out for W. So if I then add clue 4, that tells me Noah's not on the debate team, so then I can rule that out. And because Noah has the fewest credits, he cannot be participating in theater. So that really only leaves basketball for Noah. And so this forces Noah to be the basketball player, which means that then everybody else cannot be the basketball player. So when I put X's on that, now Alex has one possibility, and then I rule everybody else out for Alex's theater. So everyone else is marked out. So this is kind of a process, but if you keep your information organized, then you're able to do it. If you just had random things listed and you were trying to mentally keep up with these clues, it wouldn't work. So we need to move away from saying, oh, I don't need to show my work, I don't need to write something on paper, because we all do. And so we arrive at the answer not because of some great mathematical revelation, but because we were just able to organize who did what in a list and put it in a table so that we could use the process of elimination.